In this video, I'd like to provide solutions to these three problems. I'm going to rewrite these three numbers, 452 million, 0.0000117, and 13. I'm going to write these numbers in scientific notation. Before I do that, I want to just very quickly think about what my answer should be. I can think through this problem before I start to actually find the correct representations in scientific notation. And I can do that by first considering what do we mean by scientific notation. I know I'm going to have a value a, and this value a is going to be between 1 and 10. It's going to be less than 10 and greater than 1. It could be greater than or equal to 1. In other words, I'm going to have a 1 value or 1 digit in the units column followed by something else. So this number should generally be between 1 and 10. And I know scientific notation, I'm dealing with powers of 10, and the power of 10 is either going to have a positive exponent or negative exponent. And I know if it's a positive value, typically we associate that with large numbers. So we think about the distance from Earth to the sun. That's going to have, especially if we're talking about miles or feet or something, it's going to be a very large number. It's going to have a positive exponent. And it may not be super big, though. So if I just multiply something by 10 to the first power, I might have a relatively small number. But I know if the number itself is greater than or equal to 10, if it's greater than or equal to 10, it's going to have a positive exponent. And if it's a smaller number, so it's a very small number, we are going to expect it to have a negative exponent. And this is going to be exponents that are negative, and typically we associate that for values and numbers that are less than 1. So if we are given a number, and I already see very quickly that this middle value, 0.0000117, this is a very small number. It's less than 1. I immediately know when I write it in scientific notation, it's going to have a negative exponent. 452 million, that's a large number. It's greater than 10. It's going to have a positive exponent. And 13 is also greater than 10, so that's going to have a positive exponent. So even before I get started, I can think about what the exponent is going to be, positive or negative. Using that information, putting it all together, I know in scientific notation, I'm going to have a number between 1 and 10. So if I take 452 million and consider where do I put the decimal point in the midst of these non-zero digits, it would be between the decimal point would be between the 4 and the 5, 4.52. I'm multiplying by a value of 10, and now I need to think about the number of tens that I would be multiplying by. So I'm going to just count 1, 2, 3, 4, 5, 6, 7, 8. So this number would be 4.52 times 10 to the 8th. Common mistake is that students memorize when I go left, it's positive, or when I go right, it's negative. We want to be careful there because if you're going back and forth, you might flip-flop what you are doing with the decimal point. Are you going from here? Is it going from left to right or right to left? So instead, just think about, is it positive or negative is going to be determined whether or not we're dealing with a large number or a small number. In the second problem here, I'm dealing with a very small number. So I know I'm going to be multiplying by a power of 10 that has a negative exponent because this value is very small. How do I place the decimal point in a strategic location? Well, I need to make somehow these non-zero digits between 1 and 10. I'm going to put that right here between the two ones. So 1.17. Now the only thing left to do is to think about how many times the decimal place is moving. 1, 2, let me put a color in there. 1, 2, 3, 4, 5. So I have 1.17 times 10 to the negative 5. And finally, 13. This is a number that is larger than 10. It's a positive number. It's a number that's larger than 10. I'm not going to have a negative exponent. I'm going to have a positive integer on that value of 10. How do I make 13 a value between 1 and 10? I'm going to put the decimal point right here. So 1.3 times 10. And what is that exponent going to be? Well, the decimal point is just one place removed. So that's multiplying by 110. And I know it's positive, again, because 13 is a number that's greater than 10. This should make sense. 1.3 times 10, if you put that in your calculator, you're going to get 13.